So, hello everyone, привіт всім. Я буду говорити англійською, тому що це міжнародна конференція, можливо, комусь так буде цікавіше, зрозуміліше. Але так, розмовляю українською, тому якщо у вас є запитання, то підійдіть, будь ласка, до мене під час перерв. Я буду з вами рада поговорити або послухати про ваш досвід використання Граалю. So yeah, I work as developer advocate at Oracle Labs, and Oracle Labs is this R&D unit at Oracle. So what our team is doing is we are trying to identify, research, and implement new technologies that hopefully will be used and helpful and needed somewhere in the future. And GraalVM started as one of those technologies, and I will be happy to talk with you about today, about what it is now and what it can do for you and what it can offer you. Let's do one quick thing so that I can adjust the level of detailizations for your experience with Graal. So how many of you have heard about GraalVM? So I would say about half. And how many have tried using it? Well, obviously, Chris, yeah, I would be surprised if you didn't raise your hand. Yeah, all. Okay, so I assume you have some experience, at least theoretical experience of what GraalVM is. So just a quick safe harbor statement before we go into technical discussions. Please don't make any purchasing decisions based on the content of this presentation, even if you like it very much. I had to say that. Yeah, and let's talk about GraalVM. So to define GraalVM in one short statement, you can say that it is efficient, multilingual, and embeddable virtual machine, which is suited to serve many purposes. But how was it created and why it was even created in the very first place? So as you know, the current programming world is quite advanced and quite developed by now, but still there are many challenges. So talking about virtual machines, for example, maybe you know that implementing something like virtual machine is very high effort, right? It's not something you can implement in a day or two. And it requires quite an effort, quite a team to do that. So that's perhaps one of the reasons why even many popular programming languages still are very low performant, right? Because not every programming language has that backup behind it to build high performant implementation. And also another challenge is that conventional traditional virtual machines, they're usually suited to run one language or a very narrow set of languages. And as you think of it, it's not that efficient, right? Because every team behind those language implementation needs to do exactly the same thing. So perhaps it could be more successful if those efforts would be united, right? If there was one virtual machine that could run at least some of those languages together so that they can use this same runtime. So this was perhaps one of the goals of this research, started about 7 years ago at our team of Oracle Labs and our academic collaborators. So as you've seen, there was quite a research behind it. In fact, it was more than 60 papers. And if you are interested into digging more details, like what is this research, you can find those publications on our website. That was like the way GraalVM was created, the way it was researched, and the research there is behind it. And yeah, I recommend if you are interested in some particular aspect of GraalVM, those research papers, though they look fancy, yeah, and sound like this is some rocket science, but I recommend at least trying to read them. Many of those are quite understandable, and you can understand some of the behind the screens better. So why GraalVM? Why should you care, and what can it do for you? Well, first of all, it can give you this additional performance boost to run your Java and JVM applications faster. There are many use case scenarios where it could be implemented and give you this additional optimization so that your applications run faster. Another major advantage is our native images mode, where you can ahead of time compile your application and get this very instant startup and low memory footprint. So I guess you could say that it can be pretty useful in environments like cloud or microservices where you do care about things like startup and memory consumption because, well, you pay for that cloud, right? And another aspect is that it is polyglot and embeddable, meaning that it can be embedded in various environments to enhance those with some additional capabilities very easily without much additional effort from your side and give you these additional opportunities, for example, in things like databases. And finally, it enables polyglot programming in kind of a new way, meaning that there isn't that traditional performance drop-down. You can have this smooth, quick interop between languages, and you can actually practice polyglot programming and still have this high performance you're used to. So yeah, here is like, if there is one thing to remember from these presentations, because I assume that there will be lots of presentations today, you might be overwhelmed with the information. It could be this slide overviewing of what GraalVM can do for you. So on the upper side here, you can see the languages that we support, and below are the environment scenarios where you can use them. So obviously, you can run your normal Java JVM applications in the context of OpenJDK, meaning that you can just take your Java application without any additional customization, without any adaptation for GraalVM requirements. You can run it as it is. So like traditional Java is fully supported. Then what's kind of new, we also support dynamic and native languages. So we can also run things like JavaScript, Python, Ruby, and R. And you can see on the far right, there is C++. So you can also run native languages in a managed environment. The initial target was to focus C and C++, but basically we support everything that can be compiled down to LLVM bitcode. So you can run all of that on GraalVM in a managed environment. And talking about the environments where you can use GraalVM, so yeah, we've talked about OpenJDK, and also there is Node.js, so that you can run your Node.js apps. And talking about databases, you can use GraalVM for this new interesting scenario where you don't need to query your data first and then process it with your business logic somewhere else. You can just kind of use your business logic, use what you want to do with that data, strictly in the database with things like, for example, JavaScript, Python, using some ready-to-use solutions for your purpose. And the last but not least is standalone mode, where you can run your Java applications completely standalone, completely independent, without any external dependencies, so that you can just put your application on a server, for example, which does not have JVM, which has no idea what JVM is, and it will be fully running, fully functional, and you can use it as it is. Yeah. So how is it possible? How is it achievable? And what is all the magic behind the scenes that enables these things to be able? So in the bottom here, we have hotspot VM, like your regular Java VM. And you can see that Graal Compiler is kind of plugged into it. So this is possible to introduce since Java 9, when JVM CI was introduced. JVM CI compiler interface. So you can kind of plug in external compilers into your Java and see what works best for you. Like, for example, you have a particular workload that you want to optimize. So you can plug in external compiler and see what works best for your particular workload. Like, is it default compiler? Is it Graal Compiler? So with this thing in the basis, we can already run Java applications. On top of it, you can see Truffle, and Truffle is our language implementation framework. So with Truffle, you can implement your language to run it on GraalVM using Truffle API. But don't worry, you don't need to implement language every single time. You can just use the languages which are already implemented by our team. They're here on the above. So you can use those languages straight ahead as you go. But also, if you have some, for example, in-house developed language, or if this language is not yet present on GraalVM ecosystem, you can develop it with GraalVM Truffle. Yeah, and going into a bit more details, into monetization level. So yeah, as I said, all the JVM languages, you can run applications right onto this basement where Hotspot VM and Graal Compiler is. And Truffle enables you to run additional languages like JavaScript, Python, and so on. And something new comes here into picture, which is Ceylon. So Ceylon is enabling you to run those native languages in a managed environment. That is what it's responsible for. The way to get started, if you want to try GraalVM, is the easiest way perhaps would be to Google GraalVM or to go to graalvm.org. And there is download section where you can download. There are 2 editions: Community, which is completely free, and Enterprise, which is free for evaluation purposes. Or if you have some particular question, some particular use case, you can check our documentations. We have many use cases, many examples listed there. So that will be perhaps the way to start. Or if you are using latest Java builds, you can enable just the Graal Compiler part right in there by enabling experimental options and enabling JVM CI. So yeah, Graal Compiler. So I said a couple of times that it is efficient, that it's performant, like what makes it, where does it come from? So it's a new compiler. It's written completely from scratch, written by our team in Java. So yeah, we use Java ourselves too, so we kind of know how, for example, perhaps your working process looks day to day. It's created from scratch, created in Java. It also integrates with the Hotspot VM the way I showed before through the interface. It's modular and easily maintainable, so as it is in Java, we can introduce new features and perhaps new improvements pretty quick because it's easier to implement. It has this focus on extensibility and performance, and it offers it not only for Java and JVM languages, but rather for a wide set of languages, and they can be added even more as we go. So the way it kind of works with Hotspot VM is through JVM CI, as you've said. And what is interesting about this approach is that, for example, I don't know how many of you have tried to understand into very deep details how Hotspot VM works. But truth to be told, it's kind of hard for regular users if you are not a compiler engineer or if you are not a researcher, because Hotspot VM itself is so advanced and so complex because it offers all those possibilities, right? That for many regular users, it's kind of black box, and if you wanted to research it, it would take you quite some time and effort. So with Graal Compiler, you can kind of see how it works because it's open source, it's in Java, so you can understand how it works better. And understanding the way this compiler works can maybe be beneficial for your everyday working process because you can use that knowledge while working on your programs. So yeah, once again, I've mentioned performance things so many times by now. Let's see how it works in practice. Yeah, and I do hope that you appreciate my graphic design effort to match the theme of this presentation. So I will run this sample benchmark right now. 1 second. So I have a simple benchmark prepared here. Oh, everyone can see the screen? Okay. So I will run this benchmark and I'll explain what it does in a sec. So if you wanted to double-check numbers at home, you can run this benchmark on your regular Java setup and on GraalVM, and then kind of compare the numbers and see if this performance boost that I'm promising you is really in there. For the demonstration purposes, to do it quickly and to have this kind of completely fair competition, I will run it on GraalVM 2 times. Just one time I will disable Graal Compiler, meaning that I'll be switched back to the regular compiler, and with this one thing changed, we will see like the input of the actual compiler in the process. So I will disable Graal Compiler first. So to do that, I will use the -use GVM CI, not the shortest flag, yeah, flag. Here is my benchmark. GVM CI compiler, yeah, must be right. Yeah, and talking about the benchmark, why it is performing the measurement. Yeah, here it is. Let me go to the presentation mode. So it's a rather quick benchmark we use for the demonstration purposes. You can see that we have kind of a bunch of ints in here. We perform some streams API operations on top of that. And things like streams API sometimes can end up in kind of lowering your performance because that is something more of high abstract. So this is something you could perhaps want to optimize to make your app run really quick. So the setup of the benchmark, yeah, it has done the first measurement. So let's do the second one, and I will. Oh, what's going on? Sorry for that. I didn't realize I have my sound on. Yeah, so I assumed that didn't help. Okay. I will not be disabling Graal Compiler, so I will actually use the Graal Compiler. Yeah, so the setup of benchmark is that we have one iteration of warm-up. Yeah, you see it here. And then we have 3 iterations of the actual measurement to count the average number. The unit of measurement is, nanoseconds per operation, meaning that the lower the numbers, the better it is, because it means that we are using less time for each particular operation. So lower numbers are better. So you can see that the first time it was something like 160 176. And the second time with Graal Compiler is still counting, but you can see that the numbers are like really different even now. So the final score for Graal Compiler is 9.9. Let's count it as 10. And the first time it was 176. So the speed up in this particular case is 17x, which I think is pretty impressive. Yeah, but just here is that the speed up will not be the same in each particular case, because it will strongly depend on your workload and on your code. So before like going home and going to work on Monday and saying like we're switching to GraalVM, perhaps you would want to evaluate it first, right? Or just like every time as you switch to new technology. But yeah, there are quite a few scenarios where GraalVM can bring you speed up like this. Yeah, talking about optimizations. So there were quite a few new optimizations introduced in GraalVM. There were things like inlining, polymorphic inlining, partial escape analysis, or maybe better to say that they were they were taking new approach to implement those. So GraalVM, thanks to those optimizations, it is capable to eliminate some unneeded object allocations to speed up your applications. For example, partial escape analysis here means that we analyze the kind of escapability for each particular object, and if it does not escape the current branch, if it can be not created this allocation, it will be skipped, right? So to make your application more performant. But if it does escape, if it needs to be there in the heap, it will be created. So Graal kind of performs these very aggressive optimizations, but thanks to that you can get these batch optimizations and make your application run faster. So yeah, due to these optimizations, things like kind of more modern workloads with lots of method calls, with lots of object allocations will be running faster. The next thing I want to talk with you about is Truffle Framework. So it is the thing through which we implemented our languages I showed you on above. And if you are interested in it, you can implement your language using Truffle Framework too. Basically, all you need to do is to write your interpreter in Java, and you will get access to all these tools that GraalVM offers you, like compiler, optimizations, and so on. So what you need to do is just to write interpreter, and of course, if you want to use one of the languages that are in there, you don't need to write anything additionally. You can just use them as they are. So yeah, talking about ecosystem, it sits kind of in here and allows you to implement on those languages on top. And also it enables this interoperability between them, right? Because they are all implemented using this one approach, this one set of tools. So from the runtime perspective, they look kind of similar, and you are able to work with this thing as a whole. So if you remember that slide where there were all those languages on top and environments on the bottom, you can think of it as Graal sits in the middle there, and it provides tooling, interoperability, and optimization for the whole thing. So if you want your program to work fast, GraalVM will be responsible for optimizing this thing as a whole, so you don't need to optimize each particular aspect of that. Yeah, performance. Are there any Scala people in the audience? No? Oh, one person. I'm happy you're here. Oh, okay, two. Okay, so for Scala, as you might know, Scala produces kind of different bytecode patterns that Java does. So Graal Compiler is able to optimize those better, because those particular optimizations which are present in Graal Compiler work particularly well with Scala. So you can see here on this chart that the gray one is hotspot, the orange one is GraalVM C, and the red one is GraalVM E. So even with Community Edition, which is like fully free and ready to use, and you can use it right now in production, you can get this speed up as you go. And that's kind of great because you don't need to do this optimization by your hand. You can just use GraalVM as a drop-in replacement, and you will get these things working out of the box. In case you'll be working with GraalVM EE, you will get even more, even better performance. Performance boost would be more significant. And there is this article on our Medium blog where you can read about these kind of things, and also read, I like this one aspect where we optimize the Scala C, Scala compiler, to work faster. because as I know, that's kind of a common challenge for Scala developers, that compiler is not that fast itself. So yeah, talking about JavaScript. So here are the numbers for JavaScript, where GraalVM are both like kind of pinkish chart and red chart. So that's comparison with, for example, with Nashorn. And yeah, if you are using Nashorn, perhaps you should be considering our GraalVM JavaScript implementation, because this is the numbers that we are showing. And talking about compatibility, we are compatible with ECMAScript 2016, 17, and many of the 2018. So yeah, it's quite up to date, and I think you should try and take a look at it. Native images. So native images is the thing that I mentioned in the very beginning. What it allows you to do is to compile ahead of time your application, so it will be fully working and ready for you to use and precompiled ahead of time. And due to this, you can get this instant startup, and we will see the demo to see how instant it is. And yeah, perhaps things that you would be interested in using native images for is things like cloud and microservices, but not limited to that. Basically, it can be any other environment where you have either very expensive or for some reason very limited resources. So you might consider something like native images. So yeah, it works with memory management, secure execution, and it is ahead of time compiled using the same Graal Compiler. And here it is how it looks. So it's all precompiled and ready for you to use. This is the high-level overview of how this native image thing works. So we take your Java application, we analyze what is needed for your application to run, we take all the dependencies of the classes you need from JDK, we analyze these kind of things, and we ahead of time compile it into this native executable that is fully working and fully functional and independent of any other external things to be running. Yeah, once again, to my graphic design skills. And let's see how native image tool works. So here is my demo folder. Yeah, so you can see here that I have this list.dir Java file, and I will show you what it does in a second. But to work with native image, what you need is bytecode. So at first, I will compile it to bytecode. Oh, what's going on? The sound really freaks me out. Yeah, it is compiled, and now we can build a native image of it. So sorry for this sound. Yeah, it started working, so right now it will kind of work, analyze what's reachable there, starting from the main method, perform optimizations, inlining, compile it down, and writing the result to the disk. To show you what it does exactly, here it is, one sec. No, not this one, this one. Yeah, so what it does, it basically just a quick demo application. It walks through the directory, it looks for the files which are in there, it counts them, and it outputs the information of what it found, what is the total number of the files, and what is their size. So just a quick thing for the purposes of the demo. So yeah, it is compiled, and if we check it right now, you can see that this list.dir binary appeared in here. And now I will compare this application running in two modes, running on JVM mode and running as a native binary. So here is to run it in a standard mode. Yeah, and I will time it from the very beginning, so we will see what are they doing, but also how long it takes to run those. Please, dear. Yeah, so you can see that they performed, both applications did the same thing, right? Because the output is the same, but the numbers are very different. So the numbers, you can say, are order of magnitude different. And this kind of speed up is something you could definitely think about, for example, for your, let's say, microservices. So let's clean it up and go back to the presentation. So yeah, another example which I wanted to show you really quick is this native startup time. So once again, if there was one thing you should be like remembering about native images, because I understand that I've told a lot, would be this chart where you can see that this blue line over here is the startup time for traditional GVM setup, and this green one, which you can barely see on the top chart, is GraalVM native image startup. So startup is just so much faster, and also talking about resources consumption, about memory, it is like not that faster, but still a couple times faster. So that's talking about native images. Now, polyglot programs. I don't know if you, like somebody of you have tried polyglot programming, like mixing and matching different languages. Did you try any of this? So yeah, what you can do with GraalVM is that you can run all these languages in the context of your Java applications. You will have these security mechanisms. You will have interop, which I mentioned when we were talking about Truffle, so that will be running really smooth. And what is even better, you can use one set of tools for all the languages so that your programming process would be really fast. And it may sound like something rather theoretical. Yes, I can run my program, I can write it in many languages. It makes me such a cool programmer, so maybe it sounds more like fun than something on practical thing. But it is really practical because, for example, you can have your application written completely, let's say, in Java or basically any other language. And there may come the time when, for example, your product owner comes to you and says, like, I want to change it. I want to introduce like this huge feature in it. And you were like, oh, but it makes, this is not is possible to do really fast in my language. Like, we will need to rewrite the complete thing. And perhaps you will not be happy with this scenario, neither you nor your like client, manager, whatever. So what you can do here is that you can use that functionality from another language right in your application, and you don't need to rewrite the whole thing, because obviously there may be many objections to rewrite the whole thing. Or for example, you can use just like small parts of it. For example, Python is really trending for this like whole machine learning stuff. So you can use Python parts to kind of enhance your application with these machine learning capabilities. Yeah, to use polyglot capabilities, you'll need to install these additional components, because out of the box you will get GraalVM with Java, JavaScript, Lviv, but we assume that perhaps not everybody will be using other languages, so they come as this like addition. But it's just a matter of one command in the command line, and you can get those components, install them if you need them, or uninstall them if you don't need them anymore. And that's the way how you can get access to those. One more demo of our polyglot capabilities. Yeah, so here it is, polyglot. I guess I will build first, and I will show it to you what it does. So I have this Node.js app in there, and I will run it with our Node utility. I just need to specify that I will be running it on JVM, and also specify that I will require this polyglot mode to be so my app can run. Yeah, I guess that's correct. Yeah, it started building, and now let's see what's in there. So what's in there is this Node.js application where you can see just like regular JavaScript code. Also, you can see over there big integer coming from Java. And what is interesting here down below is this cloud plot, which is produced by R, which will include, you will see in the second, which will include this like plot of different dots. So they will be provided thanks to R functionality. So where is our, yeah, it's up and running, and spoiler alert, sorry for that. So yeah, it's the very first time, the very first request, it will require some time, because we need to initialize 3 language contexts. So as you've seen, there was Java, there was JavaScript, and there was R. So we need to initialize each of those for the application to be running. But now, as the very first request passed, you can see that we have this big integer coming from Java, we have this cloud plot, just to make sure that I'm not fooling you and it's not just some image coming from somewhere. So yeah, we are done, and let's switch back to the presentation. Use cases. So you can see Chris kind of here and there. So this is the very first example I want to show you, that this example is running from Twitter, who runs Twitter in production. And I guess I don't need to say much more because there will be a session from Chris coming in like an hour, right?
Oh, right.
Oh, okay. So yeah, let's go all to the session by Chris and see what he will tell us. And I think there will be something new today with machine learning involved, so I assume that must be interested. So I do recommend you going to that session and see what Chris prepared for us. That was the minute for advertising. Another example which I wanted to show you is coming from Goldman Sachs. Like, if you know, its company, this is big multinational financial investment institution. And what they are experimenting with is that they have their own in-house written programming language, which they created, if I remember correctly, 25 years ago. And the reason why I like it is that you can imagine, right, that 25 years ago, programming was kind of different from what we do now. So they needed to create this language themselves, because most of the languages that we would use for right now were not that able, or they were not that developed back then. So they created their own language, and you can imagine, like, if you are working on some project connected to fintech or something, that over time it became more and more advanced with new features coming. So right now it is a rather huge project, and it's very like, and it's kind of risky to introduce some big changes in there, because in this finance world, every little mistake can cause massive trouble. So they evaluated Graal as a platform to run their language on and get access, for example, to tools that GraalVM offers. So that is another example I wanted to share with you. So those were just a few examples. There are so many things that GraalVM can do for you, because, for example, if you remember that slide with languages and platforms, you can kind of mix and match those. So I don't even know if there is a limit of what you can do with it, with this mix and match principle. There is this article which I like, top 10 things which you can do with GraalVM, and kind of highlights how many benefits are in there and where you can use it. So yeah, just to summarize why GraalVM, what it can do for you. So once again, you can run your Java and JVM applications faster. You can get this instant startup and low footprint, for example, for things like cloud and microservices, where you want to start up really fast. And for example, for microservices, it gives even this additional benefit of scaling back and forth even better due to this startup and footprint. Also, it is polyglot and embeddable in various scenarios, and it offers you this smooth interoperability between different languages. Yeah, so I encourage you to go home and maybe, like, not tomorrow, not on Monday, but try GraalVM one day and share with us what is your experience with it. So if it is good, if GraalVM offered you some performance boost, some additional capabilities on your workload, so we'll be happy to hear about that. The easiest way to reach us would be through Twitter with GraalVM or GraalVM hashtag. Also, if you have some questions, we have this kind of email where you can ask those. But yeah, and also if you find some bugs or issues, or if the performance is not that good, because we consider that an issue, because we want to be really high performant, you can just report your bug at oracle/Graal. And the last and perhaps the most quick way to get in touch with Graal team would be through Gitter rooms. We have not even one, but multiple rooms where you can ask your questions, and our engineers are in there, and we are like very active, very social, and they can help you to resolve those issues. So that's about it. I want to say thank you, and yeah, and if you have any questions, yeah, please come to me, and I'll be happy to answer those. Thank you.